Hi, so in this presentation, I'm gonna talk about one of my very interesting projects, and that is fine-tuning an LLM. I'm pretty sure that you must have heard about Llama 8 billion LLM. What this 8 billion says? It says this LLM has 8 billion parameters. Let's say you need a particular behavior in your LLM. You want to embed that behavior into the LLM architecture itself. So you can use SFT followed by a DPO. But applying these fine-tuning techniques on the full 8 billion parameters is actually extremely costly. So instead of fine-tuning the full architecture, you use very efficient and clever methods like LoRA. So you can actually embed a particular behavior in your LLM by adding only about, let's say, 0.1% or 0.5% parameters. So instead of updating entire 8 billion parameters, you can save the compute cost a lot by using this method. That's what I have implemented in this project. There is another project in my CV, and that is explainable RAG. I needed a particular behavior in an LLM, and for that purpose I fine-tuned Llama 8 billion using LoRA. So you can check that project too. So in LoRA, what you do is you freeze the base model. So our base model is Llama 8 billion, and you add the LoRA adapters A and B on the output side, and only those parameters get trained. So I have two versions of LoRA, one for supervised fine-tuning SFT and the other for DPO. So first of all, let's talk about the dataset itself. So in my XRAG project, what I wanted is when user provides a query, the LLM should give the response with citations. Means it should not only give the answer using the scraped information from the internet, but also it should also tell the user from which page or from which chunk the answer is coming. So the answer I expected in this format. Now there are multiple data sets available online, free to use, exactly in this format. So in my case, I used Hagrid and WebGLM QA. So you can see the sample of these two datasets. These datasets carry query, the reference, and the response with citations. So I use these two datasets for teaching my model the structure of the response. And whenever you want to teach your LLM a particular structure in which format the answer should come out, you use here supervised fine-tuning. Now when your LLM has learned the correct format in which the response should be coming out, now you want to teach your model faithfulness, whether the generated answers or responses are actually correct or not. So for this, you apply direct preference optimization. We call it DPO. So this is the formula for DPO. So you can see here there is a reference model. So what we do is, reference model is the Llama 8 billion itself. We kept it frozen so that it generates the answer, and we penalize for the wrong answers and we reward it for the correct answers. For more details, you can go through my code. So this was about fine-tuning the Llama 8 billion LLM for our use case. So this is a success actually for us. One thing to note here, the evaluation dataset that I have used is not robust enough because of the computation limitations to calculate these scores. But for robust evaluation, obviously we should use industry standard datasets. Thank you so much for watching this demonstration.